I mean, every good game has to have a well, I guess I shouldn't say that. Has to have a weapon, right? I mean, most of the games that we like playing do some kind of shooting or whatever, and that's what I'm going to help you with here. Is that basically I'm going to show you how to build a bullet, and I'm going to make a couple of features with that. So a bullet is not a label. It's not a piece of text. It's an actor like you've been practicing with before. So I'm going to make a laser. That's what I've put in here. So I'm going to grab a laser beam. You can, if you don't have the image available, just stick something else there for now. If you don't have this one downloaded, don't worry about it. Okay? You might not even like the laser that I've got. Now, if you think about it, you know, when you fired off a bullet or a laser beam or something like that, it's actually a very simple behavior. It basically just moves. It has no control over itself. It basically just goes in the direction it was fired. You know, like a bullet can't stop and go get a sandwich at the deli. You know, it can't just like all of a sudden say, you know what, I think I'll take a nap for a little bit here and keep moving. Maybe I'll eat my neighbor's bullet or something like that. It basically just moves. That's all the behavior I would need to have in here. So in my laser, and yours might be a bullet, it might be something different, you know, a bomb of some sort. That's all I'm going to do is I'm going to say move. Okay. And the thing I don't like about it right now, maybe you guys are getting the hang of some of the style I'm trying to get rubbed off on you. I don't like the fact that this laser will only ever move with a speed of 1. That's all I can do here is move 1. I would like it to be able to move faster or slower, maybe even go backwards. All those things might be possible to me, but not the way it's coded. So let's make the laser remember how fast it moves. So I'm going to assign that speed variable to whatever you tell me how fast this laser moves. The other alternative, which you may like as well, is you can say instead of giving me this speed, I'll just make it default to 1. And I'll give you access down here by saying public void set speed. Now you can go in and say speed equals s. This would allow people still to use negatives. It even allows you to make a laser beam which has speed 0, meaning it just sits. It doesn't actually, you know, move through the space. But if you were concerned about that behavior, that's where you could check. You know, like if speed is less than 0, ignore this person or some other thing. But that's why we do it through a method, is so you can control that behavior. And somebody might want to know how fast it's moving, so let's make a method there that gets the speed. So I will return the speed to you if you ask for it. This might be useful if you're trying to figure out how fast this laser was going when it hit a character. You know, maybe if it's going faster, it does more damage. You might want to know those kind of things. So now down here, instead of hard coding this with a magic number, 1 just appears. I get to say move however fast you've been programmed to move. This is a much more versatile approach. It gives us lasers that can do all kinds of different speeds. So I'll compile this very basic laser and I'll show you what it can do. If I put one in the world, right now, whether you may or may not realize it, Greenfoot initializes everybody to be facing east, this way. So right now, this laser beam, it's pointed that way. And when I hit run, here's what happens. Pew! It doesn't make that noise, that was me. But you could program that noise if you wanted to. Okay? You may notice this, the laser gets stuck on the edge of the screen, and a lot of people get annoyed by that fact. So we can go and check if it's time to pull the laser off of the screen as well. But, you know, you might already say, yeah, that doesn't look like the way a laser moves. Well, this is probably why. It's too slow. So if I say set speed to be 5, it's better, but still maybe not what you like. But you can program it. So let's go in here. I'm going to add that feature so that that laser takes itself out whenever it hits the edge of the world. Okay, so what I'm going to check is I would like a method that tells me if I've hit the edge of the screen. So I'm just going to shrink this for a second. Here's what Greenfoot is doing. When I add an actor, this is the coordinates it uses, the very center of its image. So when you're asking about where an object is on your game, this is what you're getting back. That coordinate's where the finger is pointing right now. So that's why when it runs, the default behavior is to stop when it hits the edge of the screen. So it's going to get here and stop because that's the dead center of the object, and that's what Greenfoot uses to locate things. So when we go back to the code, that's what we're going to use to figure out if we've hit the edge of the screen. So I'll keep track of them. So the width of this screen, I can get that by first asking Greenfoot to get the world that this actor lives in. Then I can say world.getWidth. It will tell me how big this world is. I'll do this again for the height. And now I'm going to check to see if I've gotten near that edge of the screen. This laser is 50 pixels long. So what I can do is, if you want to know if you're close enough to the edge, then what we can do is use that fact that the laser is 50 wide, and we'll call it laser width. I'll get the image and get that image width. I'll also do that for the laser height. So if I want to know if I've touched the edge of the screen, what I'm going to find out is get its center X, add half the width. That'll tell me if I'm past the edge. So let's see where it is in the bounds here. For example, right now, if I was to ask, its X coordinate is where that finger is. Half of the width is this far. That gets the tip of the laser. So what I want to know is, did that go past the width of this screen? Okay, so that's a question I can ask Java. If the X coordinate plus the laser's width divided by 2 is greater than the screen width, then I can say you most certainly have hit the edge of the screen. So right now, because my laser only goes the one direction, it actually works. But we would like to make a complete method that will check everywhere it's going. Like it could go left, right, up, down. And we will use these methods here again. So the other way it could go, if we take a look at the picture, let's pretend this laser's moving this way. It hits the edge of the screen here. There's the X coordinate. Now I have to subtract half the width if I want to know where the tip of it is. So I'm going to say, otherwise, if that X coordinate minus half of its width is less than 0, because that's where the screen starts, 0 to its width, then return true. Now all we have to check is top and bottom. So it's very similar. What I'm going to do is say if the Y coordinate plus the laser's height divided by 2 is greater than the height of the screen, that means it's gone too far. It's gone past what this screen can hold for height. So here you have hit the edge. And the other one is it could be negative. So these are my 4 questions because there are 4 edges of my screen. And I think I'm actually going to make it, it's fine if it's equal because that way it is technically touching the side of the screen. I don't need it to go past that screen. But this task right here of knowing whether something in your game has hit the edge, this is a pretty common thing you'll want to know because maybe it bounces when it hits the edge. But you would deal with that behavior of your object hitting the edge, and here's how you can do it. If it didn't hit any of these edges, that means it must be a legitimate place. So I can say return false for every other question you could ask, because if it didn't hit one of the 4 edges of the screen, that means it must be within the bounds. It's still a good place to be. So when this laser beam acts, I'll go up here and say if you hit the edge of the screen. What do you think? Do you remember what I said we wanted to do? Like the laser goes to the edge. I don't want it to just sit there anymore. So what do you think the language in Java might be? What word do you think we're trying to dig up? Like, I don't know, hide, destroy. What word do you think we're looking for here? What English verb would you use? Annihilate, okay, fair enough. Maybe something a little less extreme than total annihilation. We're going to remove this thing. So again, this is why it's important to use good names, because then a lot of times you might even be able to guess what method you're looking for. So what I'm going to do is get the world, and I'm going to request that the world I live in removes this laser. And that's an important keyword for you. If you're operating on that object, the keyword to get it is this. So I'm going to say, please remove this thing from the world. Okay, so I'll compile it. And, oh, I'm on fire there. No syntax errors again. So now when I put the laser in, let's just see, before I call myself, say that I'm on fire here, I guess I should test it. So I'll put it near the edge of the screen and see if it removes itself. Boom. So it disappeared when it hit the edge of the screen. I'll show you another thing we could do. I could test it by going like this and saying set its rotation to be 90. Now that's going to point to the bottom of the screen. In Greenfoot, as all graphics are, this is a positive rotation. In this clockwise direction, that is positive rotation. So if I run it now, it should go to the bottom of the screen, and it'll say, yeah, you hit the edge and it disappeared. So it went a little further than it was supposed to, so possibly I have to look it up here. Let's just see if I made a... Okay. So that's the logic error I made there. So although my math is correct, here's the funny thing about that laser. See this? I'm calling it the width. When I rotated it, that's still the dimension that I wanted to use. See this? That is still the dimension that would tell me I went out of the screen. So I can fix that, go back. It's still going to be the laser's width that I use. So now I can at least test it and make sure that it was working the way it should. I'll put it in the world here, turn it. And now, oops, don't want to wait that long. I'll put it near the bottom. Now it should disappear a lot sooner. Okay? So the only thing I'm going to leave this off with is I believe there is a better way of doing this. First of all, I don't need to ask for that anymore. So I'm just going to remove it. The other thing is, you notice I keep asking for half of its width. So instead, I'm going to use that here. And that way I don't have to ask Java every time to divide by 2. So it's a little bit of an improvement in efficiency. It's not necessarily more correct because my program does the exact same thing. The other improvement I could make in efficiency, you know, we don't like games that lag. It's always good to think where you could save some time. I've asked for this twice, so I might as well remember it. Now I don't have to ask twice. I only ask once. So it's a little bit faster in that sense that I don't have to keep asking Java. I just remember it after I do it the first time. So those are good habits of mine to develop as a programmer. If you're repeating the same code, you may want to hold it in a variable. That way you don't have to keep asking and your game won't be as laggy. Okay, but everything here would compile and run the same way. All right, so that is how you hit the edge of the screen, take out your bullets or whatever you're doing, so you can think about what kind of weapons you want to create.